Hello students, hearty greetings of the day to one and all of you. Can you all see a pyramid on my screen? Yes. Pyramids are nothing but they were structures built in ancient Egypt in order to store wealth, arms and ammunition, food grains, etc. It is a picture of pyramids in Egypt built almost 3000 years before Christian era. How did people were able to build such huge structures in such an olden time when engineering as a branch of study was not even introduced? Have you all imagined about all those things? Yes, this was all possible because of a branch of mathematics called as geometry. Can you all see these altars here? Many ancient buildings such as temples, mosques or any kind of monuments which were built in ancient times were built so skillfully and tactfully all because of geometry. Can you all see this picture? This picture is of Opera House which is in Sydney. This picture also shows a beautiful construction. All these constructions, shapes, similarities, differences, all of them could be studied using a branch of mathematics that is called as geometry. So today we would be studying the very first chapter in geometry, or rather mathematics part 2, which is basic concepts in geometry, standard 9, maths 2, chapter number 1. Today is the first lecture of this chapter, and in this module, we would be studying about some basic concepts, coordinate of a point and distance, concept of betweenness, and we would be starting with practice set 1.1, but we would not be completing it in this module. I will be making a part 2 of this as practice set 1.1 requires much more attention and time. So let's get started. Before moving to practice set 1, let us understand the term geometry. The word geometry comes from two words, that is geo, which means earth, and metri or metria, which means measurement. So, geometry can be defined as the branch of mathematics that deals with shapes, size, similarity, measurements related to shape, etc. is called as geometry. So, geometry is basically things that are related to shape and its measurement. It was guessed that this subject, like geometry, have been evolved from the need of measuring earth, that is measuring area, measuring its perimeter, measuring volume of something, etc. Basically, measurements related to shape, the different parameters associated with them can be together incorporated and been termed as a subject which could be called as geometry. Geometry was developed in many countries. So there is no fixed period or there is no fixed person who could be said that this person has invented geometry. So geometry developed in different country in different times. Now let us understand the development of geometry in much detail. It was assumed that in ancient Greece, the first Greek mathematician was Thales. He had gone to Egypt, and it is said that he determined the heights of pyramid by measuring its shadow and using the properties of similar triangles. So this is considered as one of the events which could be termed as the origin of the subject geometry. Hence, there is no perfect evidence to where and how geometry was being developed. Now, not only ancient Greece or people of other country, but also people of India and Indian mathematicians also studied geometry in great depth. Mathematicians such as Aryabhatta, Varamihir, Brahmagupta, Bhaskaracharya, and many other of them give valuable contribution to the subject of geometry. In Vedic period, people used geometrical properties to build altars, as I've shown in earlier figure. There was also a book called as Sulabh Sutra, which describes how to build different shapes by taking measurements with the help of a string. So imagine when scale was not even discovered. Even at that time, people used to build monuments and architectures based on the measurement taken on a string. So people studied geometry much before it was being shaped into a subject per se. Now I would also want you all to know about this mathematician as well, who is Dr. Srinivasa Ramanujan. Dr. Srinivasa Ramanujan is also known as a great mathematician of India in modern times. We also had a lesson regarding him in English. There is also a movie called as The Man Who Knew Infinity, which was pictured on his autobiography. It is a bad luck of India that we lost him at a very young age of 33, but he has done a great work in the field of mathematics. Okay, so let us move to the basic concepts in geometry, which is nothing but point, line segments, ray, and plane, etc. Okay, so let us start with the very first one, that is a point. A point is nothing but it is a geometrical element that has zero dimension, which is dimensionless. Basically, a dot on a paper could be termed as a point in geometry. Point is labeled using single capital letter like capital P in this case, or you all can write it as point P also. Okay, let's move further to line. Line is nothing but it is a collection of points in a straight line. Now, line does not have an end point. Line stretches in both the directions. Hence, line is labeled using two capital letters or a single capital letter, like in this case I have used letter L. So, line can be written as line AB or line L. You all can also name line in other direction, that is BA. Okay, please do not make the symbols that I have cancelled here. Now next we move to the term line segment. A line segment is nothing but it is similar to a line, or rather it is a part of a line that contains every point on the line, but it has two end points. Like this does not stretches in both direction, but it has two fixed end points. A segment can also be labeled similar to a line using two capital letters, that is segment XY or segment YX. Do not make a bar above it. Okay. Next we move to ray. Ray is nothing but it is somewhere between line and line segment. It is a line which has one end point, but it stretches in one direction like this. So a ray has one end point and it is free to move in other direction. So ray can be extended only in one direction. Ray has a direction, so it is labeled as ray PQ, where first letter represents the end point of the ray and the second letter indicates the direction in which ray is extending. Okay, so ray is labeled like this. Next is the term plane. Plane is nothing but it is a flat, horizontal, vertical, or basically a flat surface in a space that can extend in infinite directions. Now we do not have to study plane in much detail. Plane is labeled using three capital letters, like here in this case plane EFG, or it can be labeled using one Greek letter, like we have labeled here as plane tau. This is Greek letter tau. Okay. So these are the fundamentals of geometry, which is nothing but lines, points, plane, ray, line segment, etc. So let's move further. Further, we would be learning about the coordinate of a point and distance. Now, can you all recognize this figure? Yes, this is a number line. A representation of a point on a number line is called as a coordinate. Basically, number line is a line which has numbers placed on them at equal distance from one another. Number line extends in both directions. 0 is considered as the center of the number line. And numbers to the left of the number line are negative numbers and numbers to the right of the number line are positive numbers. Generally, numbers to the right are considered greater in value as compared to the numbers in left. Any number which is represented by a point on number line can be called as a coordinate. For example, C with value -2 can be termed as a coordinate. A coordinate in one dimension is written like this: C -2, B -3, A -5, and so on. The length between two coordinates, or whichever two coordinates we are considering, or 2 points, is called as the distance between them. For example, here B and A are the 2 points which I am considering. Distance AB will be nothing but the length that comes between A and B. In this case, two numbers come between A and B. So distance of AB is nothing but 2 units. If we do not have a number line in front of us, we can use a formula to calculate distance. The formula to calculate distance in one dimension is distance equal to greater coordinate minus smaller coordinate. The coordinate that has a greater value subtracted by a coordinate that has a smaller value. Okay, so let's move towards the further concepts, but before that, note a point that distance is always a non-negative real number. That means distance cannot be negative. It is always a non-negative real number. Distance can be 0, it can be any positive number, but distance cannot be a negative number. So distance is a non-negative number, or rather it is a positive number or a 0. It should also be a real number. Now, real number is not a matter of concern here. It is just written for the sake. Actually, whatever answers of distance we are getting, all of them are real numbers in our textbook. So let us further move towards the concept of betweenness. Now, what is betweenness? Let us understand. Now, consider that there are three collinear points in space. Whenever there are three collinear points, one line can pass through it, because definition of collinearity itself says that 3 points are collinear, means one line can pass through all the 3 points. So in such case, there is a possibility that one point can be between other 2 points. So for example, if we consider points P, Q and R as collinear points, then there is a possibility that either point Q can be between P and R, either point R can be between P and Q, or either point P could be between R and Q. So there are three possibilities in which we can represent P, Q, R collinear to each other. Now, basically when we write one point between other 2 points, this is called as concept of betweenness, where we write one point between the other 2 points. They might be not equidistant from each other, but definitely one point between will be between any point between the two fixed points that we are considering. So betweenness can be shown as follows. In first case, we can write betweenness as P dash Q dash R. In second case, we can write it as P dash R dash Q. And in third case, we can write it as R dash P dash Q. Now remember, distance can be added or subtracted only when points are in betweenness. If points are not in betweenness, we cannot add or subtract the distances between them to obtain the distance of the remaining part. Okay, so let us move further to practice set 1.1. This is a very easy practice set. Let us move to the first question. First question is, find the distance with the help of the points on the number line given below. This is the number line that is shown in our textbook. Okay. So let us move further. Now the first question that we have to find is distance B. Now first of all, locate where are points B and E. So B is here -2 and E is here 5. Okay. So in order to find out the distance, what we have to do is we basically have to write the coordinates of both the points whose distance is to be calculated. So in solution, we'll first write coordinate of point B. Now what is coordinate value of point B here? B is 2. So we'll write here as 2. Next we'll find the coordinate value of E. Coordinate of point E is 5. Now next step is to compare both of them. Which number is greater than the other? So definitely 5 is greater than 2. So distance is nothing but greater coordinate minus smaller coordinate. So therefore, distance B comma E equal to greater coordinate 5 minus smaller coordinate 2. 5 minus 2 is 3. So therefore distance BE equal to 3. So we'll write the final answer as distance BE equal to 3 units, and we'll make a box to it. This is how y'all will follow the steps to calculate the distance between any 2 points. I'll show y'all one more sum. After second sum, y'all try solving this on your own and then just check with the solution in the video. So let us move to second question. Second is distance JA. Again, we'll follow the same steps in the solution. Coordinate of point J. Keep number line in front of y'all in your textbook. Coordinate of point J there is -2. Then coordinate of point A. Coordinate of point A is 1. Now definitely positive number is greater than negative number. So 1 is greater than -2. So therefore distance is greater coordinate minus smaller coordinate. So therefore distance JA is equal to greater coordinate 1 minus sign. Now smaller coordinate in itself contains a negative sign. So we'll write it like this, -2. So 1 minus -2. 2 minus will make a plus sign. So this will be 1 plus 2. So this will be 3. So therefore distance JA equal to 3. So therefore we'll write distance JA equal to 3 units and make a box. Now further on, you'll try to solve these questions on your own. Pause video wherever you all are required and note down the things. From starting, you all will write down about the word geometry, what are its meaning. Then you all will make that table of point, line and plane. Then you all will write the concept of coordinate of a point, distance, whatever was displayed on the slide. Then you all will write practice set 1.1. You all will give the heading, draw number line, write whichever distances are required, and try to solve question number 3 to 8 by your own. I am providing you all the solution in the video. Only refer to it if you all are not able to solve those sums or to cross check your answers. Okay. Now we'll move to third one. Third one is distance PC. Coordinate of point P is -4. Coordinate of point C is 3. Now definitely 3 is greater than -4. Positive number is always greater than negative number. Distance is greater coordinate minus smaller coordinate. So therefore distance P comma C equal to 3 minus -4, that is 3 plus 4, that is equal to 7. So therefore distance PC equal to 7. So we'll write therefore distance PC equal to 7 units. We'll move to sum number 4, distance JH. Now for that, coordinate of point J is -2. Coordinate of point H is -1. Now here both the numbers are negative. In negative number, smaller negative number will have a greater value. So -1 is greater than -2. So distance is again greater coordinate minus smaller coordinate. So therefore distance JH equal to -1 minus -2, that is equal to -1 plus 2. When numbers have opposite signs, subtract them. So 2 minus 1 is 1, and sign of the greater number. 2 is greater number, it has a positive sign. So this will be only 1. So therefore distance JH equals to 1, and final answer, therefore distance JH equal to 1 unit. Let's move to sum number 5. Sum number 5 is distance KO. Solution. Coordinate of point K will be -3. Coordinate of point O is 0. Now 0 is greater than negative number. So 0 is greater than -3. Distance is greater coordinate minus smaller coordinate. So therefore distance K comma O equal to 0 minus smaller coordinate -3, which is 0 plus 3, which is equal to 3. So therefore distance K comma O equal to 3. So we'll write distance KO equal to 3 units. Next we move to sixth one. Sixth one is distance OE. So solution, coordinate of point O is 0. Coordinate of point E is 5. Definitely positive number is greater than 0. So 5 will be greater than 0. Distance is greater coordinate minus smaller coordinate. So therefore, distance O comma E is equal to greater coordinate 5 minus smaller coordinate 0. 5 minus 0 is 5 itself. So therefore, distance OE equal to 5. So we'll write distance OE equal to 5 units. Now we move to seventh one. Seventh one is distance PJ. Again, solution, coordinate of point P is minus 4. Coordinate of point J is minus 2. In negative number, smaller the number, greater is its value. So minus 2 is greater than minus 4. So therefore, distance is greater coordinate minus smaller coordinate. So therefore, distance P comma J equal to greater coordinate minus 2 minus smaller coordinate minus 4. So this will be minus 2 plus 4. When two numbers have opposite signs, subtract them. So 4 minus 2 is 2. So therefore, distance PJ equal to 2. So we'll write the final statement as distance PJ equal to 2 units. Next is 8th one, distance QB. Again, solution, coordinate of point Q. Coordinate of point Q is minus 5. Coordinate of point B is 2. 2 being a positive number is greater than minus 5, which is a negative number. So distance is greater coordinate minus smaller coordinate. So therefore, distance QB is equal to 2 minus minus 5, which is 2 plus 5, which is equal to 7. So therefore, distance QB equal to 7. So we'll write distance QB equal to 7 units. So with this, we complete our question number 1 of practice set 1.1. Now we move to the second question. Question number 2 says that if coordinate of point A is small x and coordinate of point B is small y, then find distance AB in each of the following cases. So now we will be given different values of x and y, and we'll substitute it in A and B and we'll find distance AB. Now these sums are also similar to finding out distance only. First question is x equal to 1 and y equal to 7. Now what will be the solution? Let us check. In solution, we'll again write it in the same way as previous sum. Coordinate of point A. Now in question it is given the coordinate of point A is value of small x. So A equal to small x, that equals to 1 in this case. So we'll write this as 1. Coordinate of point B is equal to small y. Small y ka value is 7. So we'll write here 7. Again, compare both of them. 7 is greater than 1. So therefore, distance is greater coordinate minus smaller coordinate. In each case, we have to find out distance AB. So therefore, distance AB equals to greater coordinate, that is 7, minus smaller coordinate, that is 1, that is equal to 6. So therefore, distance AB equal to 6 units. So this is how you all have to solve these sums in question number 2. Now you all try to solve question number sub question number 2nd, 3rd, 4th, 5th and 6th on your own. If you all are not understanding these sums, you all can refer the video further. Otherwise, you all try on your own and cross check with the video whatever you all have solved in your notebooks. Okay. So we'll move to second sum. Now I would be displaying you all the solutions. Solution. Coordinate of point A is small x. In this case, value of small x is 6. Coordinate of point B is y, that is minus 2. Comparison, 6 is greater than minus 2. distance is greater coordinate minus smaller coordinate. So distance AB will be 6, which is greater coordinate, minus smaller coordinate, which is minus 2 in itself. So minus of minus is plus. So this will become 6 plus 2. So this will become 8. So we'll write therefore distance A comma B equal to 8. So distance AB equal to 8 units. Okay. Let us move to third one. Third one is x equal to minus 3 and y equal to 7. Solution. Coordinate of point A is small x, which is minus 3. Coordinate of point B is y, which is 7. So comparison, 7 is greater than minus 3. Distance is greater coordinate minus smaller coordinate. So therefore distance AB will be 7 minus minus 3, that is equal to 7 plus 3, which is nothing but 10. So therefore distance AB equal to 10. So we'll write distance AB equal to 10 units. Sum number 4. Solution. Coordinate of point A is equal to x. X is minus 4. So we'll write here minus 4. Coordinate of point B is y. Y is equal to minus 5. Now in negative number, smaller is the value, that number is more greater. Okay. So minus 4 will be greater than minus 5. Again, distance is greater coordinate minus smaller coordinate. So therefore distance AB equal to minus 4 minus minus 5. So this will become minus 4 plus 5. Now if two numbers have opposite sign, subtract them. So 5 minus 4 is 1 and sign of the greater number, which is positive in this case. So therefore distance AB equal to 1. So we'll write distance AB equal to 1 unit. Now fifth one. X equal to minus 3, y equal to minus 6. Again, solution. We'll write coordinate of point A, which is x, which is equal to minus 3. Coordinate of point B, which is y, which is equal to minus 6. Now, minus 3 is greater than minus 6 because they are negative numbers. Smaller the value, greater is the negative number. So, therefore, distance is greater coordinate minus smaller coordinate. So, therefore, distance AB equals to minus 3 minus minus 6. So, that will be equal to minus 3 plus 6. Minus 3 plus 6 equals to two numbers with opposite sign, that is 6 minus 3 equal to 3. So therefore distance AB equal to 3. So we'll write final answer as distance AB equal to 3 units. Next we move to sum number 6. Sum number 6 is x equal to 4 and y equal to minus 8. Solution. Coordinate of point A is nothing but x, whose value is 4. Coordinate of point B is y, whose value is minus 8. Positive number 4 will definitely be greater than negative number minus 8. So distance is greater coordinate minus smaller coordinate. So therefore distance AB is equal to 4 minus smaller coordinate minus 8. 4 minus minus 8 is equal to 4 plus 8, that is equal to 12. So therefore distance AB is equal to 12. So final answer is distance AB equal to 12 units. Okay. So this is all in this module. Further, from question number 3, the separate video will be recorded and will be provided. It will contain sums from question number 3 up till end of this practice set. As this practice set is a little bit vast, we are dividing it into two parts. So this was the first part. Hope you all had a good amount of practice of whether how to calculate distance between 2 points. So write down so much and meet you all in the next class. Thank you, students.